So next up, let's take a look at the graph of y equals the secant of x. For y equals the secant of x, using a reciprocal identity, that'll be the reciprocal of the cosine of x. So similar to what we did for the tangent and the cotangent, we'll start by copying down our important quadrantal angles. This time I'm not going to copy down the sine and the cosine. I'm simply going to copy down the cosine. This is due to the fact that we're only going to need the reciprocal of this rather than a sine over a cosine or a cosine over a sine. So the secant is going to be the reciprocals of each of these values. The reciprocal of 1 would be 1 over 1, that is 1. The reciprocal of 0 is undefined. On the graph, that means we will see yet another vertical asymptote. For negative 1, the reciprocal of negative 1 is negative 1. At 3 pi over 2, the reciprocal of 0 is undefined, and therefore will manifest as a vertical asymptote. And at 2 pi, the reciprocal of 1 is 1. Now, the explanation for where this graph comes from makes a lot more sense if you actually draw y equals the cosine of x in here as well. So what I'm going to do is draw in the cosine of x on this interval. So it starts at a local maximum, comes down to the midline, down to a minimum, back up to a maximum, or sorry, midline, then maximum. And this would be the graph on 0 to 2 pi. Now, to put together this graph, wherever the cosine touches its midline, the reciprocal of that is going to wind up being an asymptote. You know what? I think this will actually be beneficial if we do a second cycle so that you can see a little bit more continuity in what we're doing. So this will be 5 pi over 2 and 3 pi, 7 pi over 2 and 4 pi. So cosine will come back to the midline, down to a local minimum, back to the midline, and then up here. So again, every time cosine touches its midline, we'll see an asymptote. So I'm going to switch over to red. Red seems good. So wherever the cosine had a local maximum or a local minimum, the reciprocal of that wound up being the exact same thing. Now, keeping in mind that the graph that we're about to draw has multiple asymptotes, we'll pose the question, after these graphs are touching each other at y equals 1, cosine starts decreasing, so the reciprocal will increase. Down here, to the left, the graph is going in the upward direction, so the reciprocal should go in the downward direction. Similar logic over here. So I realize that in the last week we have discovered that many people in our classes are not homeowners, pet owners. I'm sure many of us are homeowners as well. To construct the graph of y equals the secant of x, if you know the graph of y equals the cosine of x, is to apply a certain principle. And that certain principle is known as the principle of boop. Now, for the record, if you are going to say this at home, you are not allowed to refer to this as the principle of boop. It is the principle of boop. Now, with that in mind, between any two consecutive asymptotes, here's what the graph does. It starts down at some form of infinity, and it comes racing in from infinity to go boop, and it boops it on the snoot and then runs all the way back to infinity. I will give you a demonstration during one of my lectures what it means to boop a snoot with my lovely cat Wednesday. So with these things in mind, let's take a look at the important aspects of the graph. The domain is going to be all real numbers except for anywhere that we have an asymptote. So that'll be pi over 2 plus k pi. The range on this one is rather interesting. The upper portions of the graph start at 1 and then go up to infinity, and the lower portions of the graph start at -1 and go down to -infinity. So we actually partition the range into two different parts, -infinity to -1, as well as 1 to infinity. Vertical asymptotes occur wherever we have domain issues. So that'll be at x is equal to pi over 2 plus k pi. There will be no x-intercepts. This is due to the fact that this is a reciprocal function, and reciprocals are typically never equal to 0. And then between consecutive asymptotes, the graph is smooth and continuous. I'm leaving out the part where we reference increasing versus decreasing because it's not always the same within these intervals. For example, between pi over 2 and 3 pi over 2, the graph starts out increasing but then starts decreasing after it boops the graph on the snoot. Additionally, the period of this graph is going to be 2 pi. This will repeat itself every 2 pi units. Now with that in mind, to come up with the graph of the cosecant is to do the exact same thing as what we just did with the cosine, except we'll be doing it with the sine. So for y equals cosecant of x, that'll be the reciprocal of the sine of x. What we'll do is we'll draw the graph of the sine of x, and then we will apply the very important mathematical principle of boop. So for the sine of x, taking the sine of each of these angles, sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is -1, and the sine of 2 pi is 0. For the cosecant of x, since we're getting pretty good at this, I'm going to shorthand this to say the reciprocals of the zeros that we have will all be vertical asymptotes. The reciprocal of 1 is 1, and the reciprocal of -1 is -1. I'm actually going to do 2 cycles for this, just like we did for the secant with the cosine. Oh, that graph turned out much better than the last one. Of course, now that I've said that, I'm probably going to screw something up. Oh boy. Okay, pressure's on. All right. Whew. That was close. Pi over 2, pi. 3 pi over 2, 2 pi. 5 pi over 2, 3 pi. 7 pi over 2, 4 pi. All right, so sine function. Starting at local maxima or local minima and sending them into the midline, just like so. Oh yeah, man, we're getting good at drawing these. That's y equals the sine of x. Now, the cosecant, wherever the sine has a midline, cosecant is going to have a vertical asymptote. Like so. And then in between consecutive asymptotes, we are going to apply the principle of boop. So on the positive side, we're going to boop the function right at pi over 2, 1, and then we're going to race back toward positive infinity. For the next one, we're going to boop the snoot right at 3 pi over 2, comma, -1. Then boop the function right at 5 pi over 2, and race off toward infinity again. And then boop at 7 pi over 2, -1, and race off toward infinity. And that is y equals the cosecant of x. So with those things in mind, important aspects of these mother functions. Domain is going to be the set of all real numbers except for multiples of pi, We saw asymptotes at 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. Range is going to be the same as the secant function. That's going to be from negative infinity to negative 1 for the lower portions of the graph, and then 1 to infinity for the higher portions of the graph. We will see a vertical asymptote at x is equal to k pi. Once again, we will see no x-intercepts, because this is the reciprocal of something that does have x-intercepts. Then between consecutive asymptotes, the graph is smooth and continuous. The period of the cosecant function is going to be 2 pi. Now, when we start doing examples of transformations of these functions, if you draw the transformed version of the sine function for the cosecant or the cosine function for the secant, and then apply the principle of boop, you will have the completed graph. More on that in our next video.